Good morning, Bogdan Marin here. You might remember me from such videos as the previous 3 lab videos. Now I'm here to bring you the 4th. We're going to skip ahead to a few. We're going to go to lab 2-2, series circuits and voltage relationships. So what I've done here is I've hooked up 1, 2, 3, 4, 5 loads with the cone heater. 5 loads, as you see in lab 2-2 here. So you see my 5 loads and hooked up to my DC. So I am on my DC here. I have a 60 watt lamp, 100 watt lamp, 150, 200, and my cone heater. Okay. So what you guys are gonna see here is that, excuse me. You're going to see the different voltage drops on each one. So remember we talked about the proportion and the relationship when it comes to resistance in a series circuit. So the biggest resistor in a series circuit will drop the blank amount of volts. Most amount of volts, okay? So the biggest resistor will drop the most amount of volts in a series circuit, okay? So let's take a look here and see what happens when I energize this. So I have all the loads connected in series. Now I'm going to turn this on and it says slowly turn the power supply to 120. Okay. I already had it at 120. So I guess that defeats the slowly part. Okay, well we see the 60 watt. Very bright. Okay, interesting. Okay, we don't see the other ones very bright at all. Okay, so now it's going to show us, it's going to ask us to do a couple things. So the voltage drop at the first load. Okay, well I'm going to get my digital voltmeter and I'm going to set it to volts DC. And I'm going to check voltage drop on load 1. 75 volts. So on the 60 watt lamp, I have 75 volts. Load 2, 23.7. So as I'm measuring all these guys, what do you think all of these will total to? Carry the 6, carry the 4, blah, blah, blah. No, to the source. All the voltage drops in a circuit will have to equal the source. Okay, so there's now the 151. I get 9.7 and 4.2, and my cone heater, which is the last one, I get 6. Interesting. So who would have thought the 60 watt lamp has the highest ohms opposed to a 200 watt one? Interesting. So the lower the wattage, the higher the ohms. That does make sense because to get power, you have to have current and voltage to get a higher amount of power. So if I want to allow more current to go through a light bulb, I need to lower its internal resistance, meaning that the higher wattage needs to have a lower internal resistance to allow more current to flow through it to be able to produce the 200 watts. Now this one here, the 60 watt obviously is going to have more resistance. So usually we don't put light bulbs in series. It's not a very common practice. We don't put them in series, we put them in parallel in your house. Everything's in parallel. Because could you imagine putting all your light bulbs in series in your house? So as you add more light bulbs in series, the other ones get dimmer, so you defeat the purpose of adding more light bulbs in your house. It'd be quite comical. So that's why we add everything in parallel. Okay, now let's turn the circuit off here. Short circuit, load 4 by placing a jumper across the 2 terminals. So load 4 is going to be the 200 watter. Now, be very careful when you're shorting something up. Make sure you realize what you're doing here. So what I'm doing here is I'm eliminating essentially this lamp here. Well, this lamp I knew was drawing about 6 volts, so the resistance on it is very low. So I'm not really too worried. I'm not getting rid of that much ohmic value out of the circuit. So when I turn this on, I'm not too worried here. But you are going to notice the other values are going to be stronger. The other voltage numbers are going to go up. So let's see what we have here now. I'm going to have 78 volts. My cone heater, I believe, had 6.8 last time, or 5.8. Now I've got 6.2, 25, and 10.14. So all my voltage values went up because I've shorted one. So I've eliminated one of the ohmic values. So all the other ohmic values had a bigger share of the voltage. Record all my values, what I just did. Turn this off. Adjust the voltmeter to 0 and turn power off. Oh, okay, I should have done that. Remove the shorting jumper across load 4, which is this guy right here. Remove the jumper placed between loads 3 and 4. So now I got to pull a jumper between loads 3 and 4. So that's between the 150 and 200. Pull this jumper. Okay, turn the meter on slowly. What do I get? Well, I can tell you guys right now. In a series circuit, or any type of circuit, if you open the switch in your house to the lights, what happens to your lights when you turn the switch? Well, either they turn on or they turn off. I essentially just pulled the switch here. So now there's no complete path here. So when I turn this on, nothing turns on. So if I want to put my voltmeter here, 0, 0, 0, 0, 0. Now, what happens if I put my voltmeter between these 2 points here? Ask me to open. What do you guys think I'm going to get? 0 still? I get source value of 123.9. I probably should check that. I might mess with all my numbers a little bit. So I'm going to drop down to exactly 120 here. Okay, you're going to notice as you're going through these labs with me here, your calculator numbers might be a little bit off, or they might differ from mine. So just be aware that, again, these are rough estimates. I am using analog meters in here as well. So just remember to take that in account. And again, I'll let you guys do your observations and conclusions, and you guys can get back to me with your concerns and questions. So thanks for tuning into lab, I believe this was 2-2, and stay tuned for more. Thanks, guys.